So in the last video, we talked about this oxymercuration reaction. We could now categorize this reaction as adding in a Markovnikov fashion. This is going to be your major product. Okay, so now we can compare and contrast with this reaction that we had up above. So this was an acid-catalyzed hydration. And we actually got a different product as the major product. So the characterizing feature of this reaction that we did with the slightly different reagents is we were still making alcohol. So we made an alcohol, but we went through a slightly different mechanism. So this is going through a C+ mechanism. And because of that mechanism, we are subject to rearrangements. So we have to start to worry about rearrangements with this kind of reaction. And this reaction can't really be categorized as Markovnikov because it kind of does this rearrangement. So it doesn't really fall in the right category. But now, so we have two different alcohols that we've made. One where that hydroxy group is added to carbon 2, and another one where the hydroxy group was added at carbon 3. Now, there's actually another really cool reaction that finishes up and complements these other two reactions, and it's going to be the reaction that we're talking about in this video. And this reaction is called hydroboration. So hydroboration. So we're going to have the same molecule, 1, 2, 3, 4, 5, and I'm going to number them the exact same way, 1, 2, 3, and 4. And so what I'm going to do is I'm just going to give you the A plus B equals C part of this reaction. So this is the starting material. We're going to have slightly different reagents, and we're going to get a slightly different outcome. So let me just draw the outcome, and you can see if you can compare and contrast to what happened last time. Okay, so now if I number all of my carbons, this is 1, this is 2, this is 3, and this is 4. So this is going to be definitely very complementary to everything else that we've done so far. We're still kind of starting out in the same spot. We've got an alkene, and we're going to add some reagent, and we're still making an alcohol. So we made an alcohol here, we made an alcohol here, and an alcohol here. And the only difference really is the positioning of that alcohol. So in the first example, we had it on 2, then on 3, and now for this example, that hydroxy group, or the alcohol, has been added to position 1. So I'm going to go ahead and give you the reagents for this reaction, and then we'll talk about it a little bit more, try to categorize it. So just like the oxymercuration, you have 2 steps for this reaction. So at the end of the day, if you take your alkene and you react your alkene with these reagents in this particular sequence with the BH3 first, and then these 2 reagents simultaneously, you'll get this, hydroboration hydration reaction where you get the hydroxy group added to carbon 1 and not carbon 3 or 2. So just like the oxymercuration had some interesting features, so does the hydroboration. So you can do this reaction and we don't have to worry about any kind of rearrangements. The other part that if you want to separate it from the top reaction, in this case, what we're going to have is our nucleophilic position, or our final position, which is the hydrated position. You have the oxygen attached to the less substituted position. So instead of Markovnikov, it's called, not very creatively, it's called anti-Mark, or anti-Markovnikov. And all that really is changing between these 3 different reactions is that you are just varying the position of the hydroxy group that ends up being attached to the original molecule. And there's a term for how we describe these types of reactions and how they're different. And this descriptor is going to be called regiochemistry. We would say that the regiochemistry, or the regiochemical outcome for these 3 reactions are different because the hydroxy has been added to separate regions of the molecule, or separate positions of the molecule. And so, and then other than that, we can categorize them by their overall, tendencies. So oxymercuration will always do this Markovnikov reaction. Then hydroboration will always do this anti-Markovnikov reaction. And then these acid-catalyzed hydrations, they're kind of the wild card. They give these weird rearrangements. So they don't necessarily have to get anti-Mark or Mark. They can do whatever the heck they want to do as long as they're stabilizing the carbocation intermediate. Just like with the oxymercuration, we're going to be able to treat this as kind of a black box where you don't really have to worry so much about how this works. You just have to remember the reagents. And again, if you are interested in the mechanism is in your book and it's kind of neat. So the mechanism is going to be on page 186. But other than that, you don't have to worry so much about it.